Alright, in this video we are going to talk about taking the limit of a function, also known as taking the derivative of a function. And the equation looks something like this. You have y is equal to some function of x, and we will say that the derivative of that function is equal to taking the limit as delta x goes to 0 of the function of y at the point x plus delta x, and we are going to subtract the function at x, and all that it will be over delta x. And say for example we are trying to take the limit or the derivative of y equals x. If we were to just plug that in, it would look exactly like this, and then if we let delta x go to 0, you see we're ending up with something divided by 0, which you shouldn't be able to do. But the clever trick about this formula is that most of the time you'll find some sort of cancellation. Like, for example, if y equals x, we could just plug that into this equation and see what we get. In this case, the function of x plus delta x just goes right into this variable here, and so the output is just that input. Since whatever when y equals x, whatever you put in equals that is what you get out. Like if x were 1, if x, for example, equals 1, then y would equal 1. If x equals 2, then y equals 2. So following that line of reasoning, we can say that the derivative of x is equal to the limit as delta x goes to 0 of x plus delta x. That comes from just plugging that directly in place of x, and then we subtract the function at x, which just gets passed through, and all of that is over delta x. So what we notice here is we have a positive x and a negative x. Those two end up canceling each other out, so you're just left with delta x over delta x. Now you still might say that's even worse because you're dividing 0 by 0, but the whole point of taking the limit is saying let delta x get as close to 0 as possible without actually being 0. So what we're really saying over here is take a very, very small number and divide it by that same very, very small number, and we know anything divided by itself is equal to 1, so the derivative of x equals 1. So that's the first problem we're going to look at. The next problem is, what if we wanted to take the derivative of x squared. How do we figure that out? Well, we would say that, and the derivative, by the way, can be written as y prime. If y is a function of x, then y prime is the derivative of that function of x. You could also say if y prime is a function of x, then f prime is also known as the derivative. You might also see it written as the change in y over the change in x. As that change gets smaller and smaller, you end up with dy dx. So all those are equal to the derivative. So y prime of x squared is equal to the limit as delta x goes to 0 of, I'll write it again, f plus delta x minus f of x over delta x. So that's the setup. Now all we need to do is plug this in place, this and this into here, and we see what we get. So that's equal to the limit as delta x goes to 0 of, put in parentheses, x plus delta x squared minus x squared over delta x. And I got this just by plugging in this directly in place of x squared. If y equals x squared, this goes into here and gets evaluated, and that's what you get. And then this gets put into here and it's evaluated here. So now what we need to do is expand this first part out to get x squared plus 2x delta x plus delta x squared minus x squared over delta x. So let's see, we have a cancellation, we have x squared minus x squared, and then we see that there's a common factor of delta x in the numerator and the denominator, so we can factor that out. So you're left with delta x over delta x times 2x plus delta x. And then, like we said before, anything divided by itself is 1, and all we're left is 2x plus delta x. And if delta x goes to 0, all we're left with is 2x. So the derivative of x squared equals 2x. And the very last one I'm going to go over is the derivative of x cubed. And that equals, like we said before, the limit as delta x goes to 0 of f of x plus delta x minus f of x over delta x. So if y equals x cubed, we put this first part into that and we get the limit as delta x goes to 0 of x plus delta x cubed minus, putting x in place of x, we get x cubed over delta x. Now, expanding this one out is a lot, but if we look at it, x plus delta x times x plus delta x times x plus delta x minus x cubed, and that's over delta x. So what do we get? We're going to get delta x cubed plus x delta x squared plus, let's see, so this is 0, 0, 0, 0, 0, 1, 0, 1, 0 is still x delta x squared plus 0, 1, 1, that's x squared delta x, and then 1, 0, 0, you have x delta x squared plus 1 is x squared delta x plus 1, 1, 0, you have x squared delta x plus x cubed. And then don't forget we have a minus x cubed all over delta x. So x cubed cancels out, and then all these have a factor of delta x. So again, we factor out delta x over delta x, and we are left with delta x squared plus x delta x plus x delta x plus x squared plus x delta x plus x squared plus x squared. And so anything divided by itself is 1. Anything with a delta x in it goes to 0, and you are left with 3x squared. So that is the derivative of x cubed.